So today we went over how to find the derivative of a function using implicit differentiation. So first what we need to do is go over the difference between implicit form of a function and explicit form of a function. So implicit means that you don't have one variable isolated, and explicit means that one of the variables is completely isolated. We're used to having y equals. So our first example, implicit, would be x plus y squared is equal to 7. That's the implicit form. Now, explicit means I would rewrite it so it says y equals. Well, how would I do that? Looking at the original equation, if I subtract x from both sides, I would have y squared equals 7 minus x. But I don't want y squared, I want just plain y. So to get rid of y squared, I square root both sides. And then whenever I write a square root, I need to put a plus or minus in front of it. This is the explicit form of the function x plus y squared equals 7. Another example would be if the function was xy is equal to 3. How would I write that so it says y equals? And that one's a little bit easier. All you have to do is divide both sides by x to get rid of the fact that you have xy, and you get 3 over x. That would be the explicit form of that function. The question is, can all functions be written in explicit form? The answer is no. Not all functions can be written explicitly. For example, x squared minus 2y cubed plus 4y equals 2. Let's try to write it so it says y equals. First thing you would do is subtract x squared from both sides. Well, that will leave you with negative 2y cubed plus 4y is equal to 2 minus x squared. And then if you were trying to get the y by itself, the only thing I can think to do with the left-hand side is factor. So I'm going to factor out the GCF, in this case negative 2y. That leaves me with y squared minus 2. And then the right-hand side is unchanged, 2 minus x squared. From there, I would want to get the 2y by itself, but that means I would have to divide by y squared minus 2. And then, even though I'm going to eventually get to y equals, my problem is over here I have both x's and y's, which means I cannot get this function written explicitly in terms of y equals. So how would I find the derivative of this function since I can't rearrange it? So we use a process called implicit differentiation to find a derivative when it cannot be written explicitly. We're going to differentiate our terms involving x like we normally would, but when differentiating a term involving a y, we're going to apply the chain rule because y is going to be defined in terms of x. And I'll explain that a little bit more with our first example. So, we're going to find the derivative of each of these expressions. Keep in mind these are expressions, not equations. All right, problem number 1. We have the derivative of 3y to the 5th, but we're doing it with respect to x. See how these two variables don't match? That's because y is a function in terms of x. For example, we've done 3 times x squared minus 4 to the 5th. And that always revolved around the chain rule. So we're going to apply that idea, only we don't know what's inside the parentheses. We don't know that it's x squared minus 4. We just know that y is some function of x. So the derivative that we want to find, we're going to apply the power rule to 3y to the 5th. That gives me 15y to the 4th. But since y is some function in terms of x, I have to multiply by its derivative, dy dx. So whenever I do the derivative of a y variable with respect to x, I'm going to do times dy dx, the derivative of what's inside that function. I just don't know exactly what that is. So I write dy dx instead. For our next one, the derivative of x squared is just 2x. There's nothing extra needed there because the variable in here matches the variable here. Since they match, nothing special needed. But now, this is different. I have 4y squared. If I use the power rule, I get 8y. But since I don't know what y is in terms of x, I have to do times dy dx. And that expression would be the derivative of this expression. For the last one, again, I have one term but two variables. So this is x cubed times y squared. I have to use the product rule. So we're going to break it apart and use the product rule. And this will happen whenever you have one term with multiple variables in it. So I start with the derivative of x cubed is 3x squared. And then I leave the y squared alone. No dy dx here because I didn't change the y term. Plus, now I do x cubed, leave it alone, times the derivative of y squared is 2y. Since it's a y, I do times dy dx. And as far as cleaning this up goes, just put your coefficients out in front. So my final answer for this problem is going to be 3x squared y squared plus 2x cubed y dy dx. I tend to leave my dy dx's at the end. So that's the derivative of an expression. Next, I need to do the derivative of an equation, which isn't too much of a stretch. All I need to do is do the derivative of both sides. So, if I do the derivative of the function 2x squared plus 3y is equal to 10, the derivative of 2x squared will be 4x. The derivative of 3y would be 3 times 1 times dy dx. And the derivative of 10 is 0. Don't forget to do the derivative of the constant. That's the most common mistake I see. So now I want to rearrange to get dy dx by itself. I'm going to subtract 4x from both sides to get 3 dy dx equals negative 4x. And then I'm going to divide through by 3 and end up with the derivative is equal to negative 4x over 3. And some of you are going to tell me, well, you could have gotten that just by rearranging the original equation. And you're right. But don't forget, not every equation can be rearranged. Problem number 2. Y squared is equal to 5. Remember, this is product rule because there's two variables in one term. So I have to use the product rule. So the derivative of x is 1, and then keep the y squared unchanged, plus the x times the derivative of y squared, which is 2y dy dx, equal to the derivative of 5, which is 0. So now I have y squared plus 2xy dy dx is equal to 0. I want dy dx equals, so I'm going to subtract y squared to get 2xy dy dx is equal to negative y squared. And now I'm going to go through and divide by 2xy to make those go away. So my answer is going to be dy dx equals, see how I have negative y squared over y? That can reduce down to just negative y over, and now I'll have 2x. And you should always reduce as much as possible. Our third example. If I do the derivative of y cubed, I would get 3y squared dy dx plus the derivative of y squared, 2y dy dx, minus the derivative of 5y, which is just 5 dy dx. All of that is equal to the derivative of x squared, which is plain old 2x. Don't forget to do the derivative of both sides. So see how each term over here has a dy dx in it? 1, 2, 3. I'm going to factor that out like a GCF. And that leaves me with 3y squared plus 2y minus 5, close parentheses, equal to 2x. So my final answer here should be relatively easy to come up with. divide through by what's in the parentheses. dy dx is equal to 2x over 3y squared plus 2y minus 5. Now the denominator is factorable, but that's not going to help me to reduce anything, so it's not worth factoring. All right, 2 more examples, then one slightly different. If I want to find the derivative of square root x plus square root y is equal to 8, the first thing I need to do is rewrite it. I need fractional exponents to apply the power rule. So I have x to the 1/2 plus y to the 1/2 is equal to 8. From there, I can start doing the derivative. Power rule says bring the exponent down, keep the variable, subtract 1 from the exponent, so I get 1/2 x to the negative 1/2. Since the y is the same exponent, it works out almost identical. 1/2 y to the negative 1/2. But this one has times dy dx because it was a y. This is equal to 8. Except it's not equal to 8 because I have to do the derivative of 8, which is 0. So it's really equal to 0. Please excuse me. So now I can't leave negative exponents, so I'm going to write this as 1 over 2 square root x plus 1 over 2 square root y dy dx is equal to 0. If you want to leave it as x to the 1/2 and y to the 1/2, that's fine too. Now I'm going to move the x term to the other side by subtracting it. And then I'm going to have to do something else to simplify a little bit more. So I have 1 over 2 square root y dy dx is equal to negative 1 over 2 square root x. I need to get rid of the 1 over 2 square root y, so since it's a fraction, I multiply by its reciprocal. 2 square root y times 2 square root y, and that will eliminate it on that side of the equation. The 2's on the right-hand side are going to eliminate also, so this answer, dy dx, is equal to negative square root y over square root x. You do not need to rationalize. You can leave your answer just like this. But you do need to reduce the 2's down. Okay, example number 5. The derivative of x squared is 2x. And then this requires product rule. So the derivative of x is 1, and then I have y, plus x times the derivative of y dy dx. Again, equal to 0 because there's a constant on the other side. I need to solve for dy dx, so I'm going to subtract 2x and subtract y, and then I'm going to go through and divide by this x here. So I'm going to get dy dx is equal to negative 2x minus y all over x. And that problem is finished. But we're going to look at number 5 a different way. Problem number 5 could be done explicitly. If I rearrange this equation, how could I get y by itself? Well, if I subtract x squared from both sides, I would get 5 minus x squared, and then I would have xy, so I'm going to divide through by x. To find the derivative of that, I'm going to use the quotient rule. So, if I do dy dx, derivative, is equal to, I'm going to do low, d high, negative 2x, minus high, 5 minus x squared, d low, which is 1, all over low squared. And if I clean that up a little bit, take a look and get rid of your parentheses, you're going to end up with negative x squared minus 5 all over x squared. The question is, how is that the same as what we got before? So how is it the same as dy dx equals negative 2x minus y over x? And that's a really good question. Here's what we're going to do. See this y here? Well, it's the same as this y up here. I'm going to do substitution. So, negative 2x minus y is really minus 5 minus x squared over x. And then that's all being divided by x. The question is, can I make that look like the answer that we just got, negative x squared minus 5 over x squared? The best way to get rid of a fraction in a fraction is to multiply by the denominator in the numerator. So I'm going to multiply by x on the top and x on the bottom to get negative 2x squared minus, the two x's here are going to eliminate, parentheses 5 minus x squared, and now it'll all be over x squared. And if you reduce that down, you're going to get negative x squared minus 5 over x squared. So they are the same. So it doesn't really matter which way you do the problem, because it could be done implicitly or explicitly and get the same thing. All right, the last thing we need to do is find the instantaneous rate of change. Now, you should know that instantaneous rate of change means find the derivative. So we need to find the derivative of our function. Our function is 3xy squared plus x squared y is equal to 2. This has product rule in it. This has a different product rule in it. So here we go. The derivative of 3x is 3, keep the y squared. Plus, keep the 3x, multiply by the derivative of y squared, which is 2y dy dx. Plus, now we need to do the derivative of x squared y. The derivative of x squared is 2x, keep the y, and then the derivative of the other way around is x squared times dy dx. And that's all equal to 0, the derivative of 2. So I'm going to do a couple simplifying steps all at once here. These terms are going to get moved to the other side because they don't have a dy dx in it. So I'm going to have negative 3y squared minus 2xy. And then on the other side, I'm going to factor out the dy dx. I'll be left with 3x times 2y, which is 6xy, and then plus x squared. Divide through, and you get dy dx is equal to negative 3y squared minus 2xy all over 6xy plus x squared, which looks like it can reduce, but it really can't. Up top, all the terms have a y in them. On the bottom, all the terms have an x in them. They don't all have something in common, so I cannot reduce. The difference is, how do I deal with instantaneous rate of change at a point? Before, we always just plugged in an x value to get a numerical value for the slope. Now I have to plug in two numbers. X is 2, y is negative 1. So I'm going to have negative 3 times negative 1 squared, which is really just negative 3, minus 2 times negative 1, negative 2xy, which is really just plus 4, all over 6 times 2 times negative 1 plus 2 squared. If you do all of that out, you're going to get a final answer of negative 1/8. And that is our instantaneous rate of change, or the slope of our tangent line at that point. If I wanted to write the equation of the line, I would use point-slope form using m equals negative 1/8 and x and y are 2, negative 1. I hope you found this helpful. See you in class.